All right, it's time to review a little bit of density. Density is a physical property. What does that mean? Well, that means we can observe it without changing the chemical identity of the substance. So I can find the density of water without trying to turn it into something else. I can find the density of gold without trying to change it into something else. In fact, I can find the density of anything, even something I don't know what it is, without changing the substance. It is also unique for each substance. So that means we can use it to identify the substance. So if I'm like, here is the density, you could look up and say, oh, now I know what that is. When you're trying to identify a substance using its density, right? And especially you're trying to find out what an unknown is, you have to measure the mass, so use a balance. And then you have to find the volume. Now, if it is a geometric shape, we can use a ruler and do calculations that way. If it is not, we can use a graduated cylinder. Put a known amount of water in the graduated cylinder, put the object in, see how much the volume changes, and now we have the volume. So we have mass from the balance and volume, either from doing the volume calculations for the geometric shape or from water displacement, and then we calculate density. Now, density for an element is located on table S. So if you look right here, there is a column that is density. Now, the units are given in grams per centimeter cubed, but what you should know is that a centimeter cubed is identical to a milliliter. So if you see those measurements used interchangeably, keep that in your head. All right, density for water is about 1 gram per milliliter or 1 gram per centimeter squared. And so you can see that is exactly what it is at 4 degrees Celsius. You can see as we cool down water, its density changes, and as we warm up water, its density changes. So temperature has an effect on density. Now for water, this is very unique, okay? So density is how compact or how many particles are in a specific volume, how tightly the particles are packed. So if you have a solid, you have high density. If you have a liquid, you have medium density. If you have a gas, you definitely have low density. An object is going to float if it is less dense, and it will sink if it is more dense. So density helps us to determine floating versus sinking. All right, a density column, we can show substances in layers based on their density. So the lower density liquids will float on top of other liquids, and then substances will be suspended between the layers where they would float and sink. The density formula is found on table T. Let's try an example problem. So the volume of a sample of aluminum is 13.4 milliliters. Calculate the mass. Okay, so here's the formula. That means, what do I know? I know this, which is volume. I need to calculate the mass. So that means I have to find the density from somewhere, but there's no other number in the problem. If there's no other number in the problem, what should you think? Oh my goodness, it's on the reference table. So where can I find density on the reference table? Yeah, on table S. I just look it up. So you find aluminum and you see that is its value. Now I plug the numbers in where they belong. Now, before you start to solve this problem, if you are math strong, do this how you want. I'm going to show you a way where students make less errors. I'm going to put this side over 1. Why? That doesn't change the number. I can divide anything by 1 and it's still the same number, right? And now I can cross multiply. So I get this when I cross multiply, okay? I plug those numbers into the calculator. That equals M. And what did M stand for? Mass, right? So that unit is grams, okay? Let's try another problem. The mass of a sample of lead, so I know the mass. Calculate the volume. I'm trying to find volume. So that means what? Again, I need density. It's not in the problem. Where is it going to be? The reference table. and it's lead, so I look it up, okay? Plug the numbers where they go, and again, how do I solve this? Put this over 1, cross multiply. I get this. This time my answer isn't just ready, right? I have 11.3 times V, but I want V by itself because that's a variable I'm solving for. How do I get V by itself? I need to divide both sides by 11.3. Now I plug that into the calculator and I get 4.9, and that's V, but I need units, not the V, so that is milliliters. All right, let's try another problem. The mass of a metal block, bam. The volume is determined to be, oh, bam. What substance is it made of? Ooh, okay. Well, I know that density is unique for each substance, so maybe I should find the density first. So plug those numbers in, and this is simple. I don't have to put that over 1 because I just divide those numbers and I get this. But the question didn't ask me for density, it said what substance is it, right? So how do I do that? Well, I look up 7.87 on table S and I found out what substance it is. It's iron, or Fe. Notice the E is lowercase. Don't forget. All right, why is the density of a substance different in different states of matter? Density depends on how tightly packed the particles are. In solids, the particles are packed tightly, so the density is higher. Also, when I increase the temperature for pretty much every substance except for water, right? But when I increase the temperature or decrease the temperature, the density is going to change in predictable ways. Increase the temperature, the particles move further apart, they're less tightly packed, density goes down.